video we're going to look at an example of an application of trig functions, pretty much right triangle trig, where we have our angle in degrees. So make sure when you're doing any of these sections that you check your mode that your calculator is set in before you start working the problem, because it's really easy to forget to check it when you're in the midst of everything. And make sure if you're supposed to be working in radians, you have it in radian mode. If you're supposed to be working in degrees, have it in degree mode. But this has a concept in it that is called bearing. So I wanted to give an example that involved the idea of bearing and how we would be able to complete the answer to this application problem. It says the bearing of Madison, Wisconsin from Stevens Point, Wisconsin. So you're looking at having your anchor place be Stevens Point, and you're guiding towards where Madison is from that reference, is south 4.1 degrees east. So when they give you the bearing from one item or one location to another location, or from one ship to another ship, or however they do the setup of the application you're doing, they'll give you the axis that you're going to go off of for the north-south first, and then tell you the degree measurement that you're going to come off that axis towards the direction of either east or west from that. So the thing here is that these angles are not trig angles in standard position like we talked about in our work with just looking at the basic definition of a trig angle in standard position. This is an application of our right triangle trig, or later on when we're doing laws and cosines, law of sines and cosines, but an application of it. And there's a lot of different venues where trig is used, and they have the convention that they set up in that venue. And so we just need to be a little bit more comfortable with a lot of different ways that information is portrayed to us. So here it's off the south axis, 4.1 degrees towards the east is where we're going to write that 4.1 degree angle. Now the straight line distance between the two cities is 108 miles, and it asks by how much is Madison east of Stevens Point. So it's not straight east, but if you looked at it on a map and you saw where Stevens Point is, where Madison is, and if you were to come down from Stevens Point until you were straight west of Madison, how far is that length? That's what they're asking us. So we're going to set up a coordinate plane, but with our coordinates, we're going to do the directional coordinates. And remember, we have north, south on the vertical axis, north being up, south being down. And then when you're thinking about this, we need to do our west and our east, and if you are facing north, then east is over towards the right and west is over towards the left. Now some people like memory devices, and a memory device for setting up your coordinates with this is, your directions with this, is that it spells we when you have your west, east. Okay, so you've got north is up, south is down, and then you have west is to the left, east is to the right. Okay, now it says that the bearing of Madison from Stevens Point, so at the origin, this is where our Stevens Point is. So we put that city, because it's from there that we're doing the bearing, we put that at the origin. Now its bearing is south, so I'm going to come off the south axis, 4.1 degrees towards the east. So 4.1 degrees towards the east. And 4.1 degrees is really little, but we're going to make it a little bit bigger than it would be, just so you can see it. Okay, so that's my 4.1 degree angle is right there. Now, once I'm down to where it's directly across from Madison, I can bring my horizontal over, and that's where you have your right angle for the right triangle trig. So then our dot for Madison, Wisconsin is right down here. Okay? Now, what other information do they have? Well, it gives me that the straight line distance between the cities, so the straight line distance between the cities is 108 miles. So that's 108 miles, it is in the right triangle, then the side opposite the 90-degree angle, so that's the hypotenuse for this application. It asks me by how much is Madison east of Stevens Point. So it wants me to find this little piece of the triangle here. Okay, we have our right angle, so we have the right triangle trig that we can use. We have this angle, we want to know this side, and we know that side. Now, when I think about this angle, it is in the triangle. Sometimes on some of these application problems, you might have to use your ideas of your theorems from geometry with parallel lines cut by a transversal that alternate interior angles are congruent, things like that. But it worked out here that our angle is in the right triangle. And again, this is not a trig angle in standard position, so I am not forced to go to the nearest x-axis for this like I had to do when I was working with the information with my trig angles in standard position to get reference angles. I'm not doing a reference angle, I'm doing a right triangle to apply my right triangle trig. Okay, so here's the angle. Now the sides that I want to know is opposite that angle, and the side that I do know is the hypotenuse. And so then I think, what trig function relates the sides of the right triangle that are the opposite and the hypotenuse? So you go through and you think of all of your right triangle trig ratios that are set up, and the trig function that relates the opposite side and the hypotenuse is the sine function. So we have the sine of 4.1 degrees is equal to, and remember it's equal to opposite over hypotenuse. So that's going to be x over 108. And this setup has to go with the way the ratios are supposed to be. So if it would have told me how far east Madison is of Stevens Point and wanted me to find the straight line distance, then I would have put the number up here and the x down there. It just is however you have to set it up for the definition of the ratio. Okay, now another thing that I want to make sure that you kind of are aware of is that there is a connection between the significant figures we are supposed to use in our side lengths of our triangles when our angles are given to specific place value rounding. So you don't do the same type of thought process with the sides and the angles. You do a significant figure for the sides, and you do place value approximations for the angles. Now, if the angles are to the nearest degree, your sides will be left in 2 significant figures. If your angles are to the nearest tenth of a degree, your sides need to be left as 3 significant figures. And then the nearest hundredth of a degree for the angles would be 4 significant figures for the sides. Okay, so I have to the nearest tenth of the degree for the angle, and they did give me this as every non-zero digit is significant and any zero between significant figures is significant. So this has 1, 2, 3 significant figures. Okay, so that's how we work with this. Now I want to solve this equation. I can solve this for x by multiplying both sides by 108 to get rid of the fraction. And that gives me that x is equal to 108 times the sine of 4.1 degrees. And then when I go through and I multiply this out and round it so that it has, or leave it so that it has 3 significant figures, we get x is approximately equal to 7.72 miles. So Madison is approximately 7.72 miles east of Stevens Point.